Student, in the last class we have discussed about DDA algorithm, and today we are going to discuss about the second line drawing algorithm, that is Bresenham algorithm. But before going to this, I would like to give you an example of DDA algorithm again so that you can understand it better. Now here you can see one example. Question is that you need to draw a line from point 1.1 to 0.59 using DD algorithm. Now for B, x1 is 1, y1 is 1, q, x2 is 5, y2 is 9. Now difference dx, difference x2 minus x1 is 4, dy y2 minus y1 is 9 minus 1 equal to 8. So uh, number of points to plot, or you can say steps. We have discussed this point also. In this algorithm you can find here steps. Okay, the steps is calculated depending upon the value of the dx and dy, and dx and dy was calculated using the values of the points. So here you can see max of absolute dx and absolute dy. Okay, the difference might be in float also, or you can say decimal value also, but we need to take the integer value. So max of 4 and 8, max of this difference is 8. So our number of points to plot, so from 0.1 to from 1.1 to 5.9 we need to plot 8 points. Okay, now in x direction, how the increment will occur? So dx by number of points to plot. That way that x will incremented. Here you can see in the algorithm also x increment is equal to dx by number of steps. So again, then in y direction that will be 1, because 8 by 8 is 1 and 4 by 8 is 0.5. Now here you can see, to this type of problem, if question comes in the exam to do the long type of calculation, I advise you to do this way, because in this way the error will be less. Now here you can see steps x and y. Okay, steps for x and y, how that x and y will vary if we go through the 8 steps or 8 points. So x, initial point of x and y was 1 and 1, and thus it will increment by the value of incrementation value, so 0.5 and 1. So the plot becomes 1.5 and 2, but we cannot plot 1.5. that is why we need to take nearest of them. So it might be 2 or it might be 1, it might be 2 or it might be 1. Okay, and then so we might need to take the floor of 1.5 or the ceiling of 1.5, and in that way so in the next stage that 1.5 will be here, that 1.5 will be here, and that 2 will be here. Okay, and again it will be incremented by 0.5, and again it will be incremented by 1, because the incrementation value of x and y are this. So again we get the 2 and 3, so this is the directly decimal, directly integer value, then I directly plot that. And again here 2 and 3, that 2 is here, that 3 is here. Okay, and again adding that, and we take the closure of that value. 2.5 is 2 and 4. You can take the floor or you can take the ceiling of 2.5. You can take also 3 also, that is your choice. Okay, in that way we can calculate the all 8 points and we will get the final point, that is 5.9 given. So in that way you need to go through the calculation, and you can see if you plot that points, if you plot them points in a graphical way, you can see this is the first point, initial point, this is the last point, and we go in that way. Or you can, if you take the ceiling of these fractional values, then your point will be like this will be here, next this will be here, next this will be here, next this will be here, in that way. So but the line will be like that. Okay, so this is the way to do the calculation for DDA algorithm, and this is very important perspective with exam also. And please try to do one example like this. Okay, so now we'll go through the Bressenham line drawing algorithm. So an accurate and efficient raster lining generator algorithm developed by Bressenham. Okay, it can converge line. So this one also a scan conversion algorithm like the DDA, using only incremental integer calculation that can be modified to display circle also or curve also. Though this algorithm is applied for line drawing algorithm, but you can modify it to circle and curve also. And based on this slope, we take the unit step in one direction and decide pixel of other direction from two candidate pixel. Means there will be two candidates that are going to be plotted in the graph, but among these two candidates we need to choose one according to the slope we get and the direction we get from the calculation. So there are some conditions. Here you can see one condition is that if del x, difference of x, is greater than del y, we sample at unit x interval, and vice versa. Vice versa means if y is greater than, then we take sample at unit y interval. So suppose example is like del x greater than del y and del y is positive, initial point will be that one. Suppose initial point is this one, line part will be in that direction, candidate pixel is this way, so x will be incremented, okay, and then y will be incremented, x will be incremented and y will be incremented. So these are two candidate pixels. So as I have taught, here you can see del x is greater than del y, and that is positive, and initial point is xk when yk, suppose this one, then our candidate pixel will be these two, xk plus 1 and yk, and or xk plus 1 yk plus 1. Now we need to decide which candidate pixel is more closer to actual line. For that we use decision parameter pk equation. So now here we decide which these two blocks are more closer to the line, and according to that we'll draw the line or draw the points, draw the pixels on the monitor, and that will be decided using this decision parameter equation. Decision parameter can be derived by calculating distance of actual line from two candidate pixel. So we know that the equation of line is y equal to mx plus b. Okay, y equal to mx plus b, an actual value at xk position. Suppose this is a k position, mxk plus b, then xk plus 1, in that position it will be incremented. Distance between actual line position and lower candidate pixel is this one. Distance between actual line position and the lower candidate pixel. Okay, actual point, okay, actual line position and lower candidate pixel. So this actual line position might be decimal value also or fractional value also. Okay, and here this part lower candidate pixel might need to be integer value, and here in this equation we can put y equal to this equation. Okay, x, we are finding that xk plus 1 position. So at xk plus 1 position there are two candidates. Okay, so we need to find which candidate is going to be closer to the line. So d1, the distance between actual line position and lower candidate, is calculated by y minus yk. Y is the actual line, yk is the candidate pixel. Then d1 equal to, and we can replace this by this equation. Distance between actual line position and upper candidate pixels. So now the upper candidate, we can put yk plus 1, because initially this one yk, this one yk plus 1, and we can put the equation of y here, equation of y here. So in that case you can see here that yk plus 1 minus y, because this is upper and this line is going lower, that is why yk plus 1 minus y. But in this equation y minus yk, because y upper from this pixel, that is why y minus yk. Now we need to calculate d minus d1. Here we try to find the d1 and d2. Now we try to find the difference between d1 and d2. d1 minus d2 is by putting the equation. So if we simplify that, we will find this part, then this, and we put m equal to del y del x at every position. Here you can see m is taken common from this, and rest of the things will be cancelled out. Okay, this will be cancelled out. Okay, okay, few things will be cancelled out here, and in that way equation will be like this one, and we can put m equal to del y by del x. So now here you can see decision parameter pk equal to del x d1 minus d2, means that del x part is multiplied with this part. So pk will be del x into this equation. So our decision parameter equation is this one. Try to remember this is important. Okay, pk equal to del x d1 minus d2. Now del y, del x is cut down, to del y is remain, then we simplify that. Okay, and this value is constant, but because this difference will be constant for all the points to be plotted, and this del x will be constant, this is already the intersection point, this is also constant, so this is the constant, a single constant, but we remain with this part, this into this and this into this. Okay, so the equation becomes like this. Similarly, for pk plus 1, next point. This is the first equation for pk. This will be this point. So subtract pk from pk plus 1. We subtract these two equations. Then what will become? So this will become like this: twice del y, xk plus 1 minus xk, yk plus 1 minus yk, xk minus xk equal to 1, because this is the 1 pixel. This difference will be always 1. Okay, so it will become like this. pk is transferred here, twice del y, because this is 1 minus this, and here where yk plus 1 and yk equal to 0 or 1 depending on the selection of the previous pixel. Okay, that is the decision factor here. The first decision parameter p naught is calculated using equation pk. So putting k equal to 0, this will be this one in this equation, okay. Now we can substitute that value of b equal to y naught mx, and then we find, again we substitute m equal to del y by del x. Okay, actually we are trying to convert it to all x and y for p naught. So p naught becomes this one. Okay, so initial decision parameter with all terms are constant. So initial parameter with all terms are constant. So now our algorithm starts: input the two line endpoints and store left endpoint in x0 and y0. Load x0 and y0 in the frame buffer, that is plot the first point. Second, we calculate these values: this twice del y, twice del m minus twice del x, and obtain the starting value for decision parameter as p naught equal to this. At each xk along the line starting at k0, perform the following test. If pk means for subsequent k values, the next point to plot is xk plus 1 yk, and in that way pk will be added twice del y, because this value will become 0 if pk is less than 0. If pk is less than 0, it means there is no change in x direction, and that is why pk plus 1, or you can say decision value will be pk plus 1 and pk plus twice del y. Otherwise the next point to plot is, if pk greater than 0, it means there is x and there is going to be in x direction. So this is the equation. Okay, we'll choose this plot, otherwise we'll choose this plot. So repeat step 4 del x times, because we are going in del x direction. The SNM algorithm is generalized to lines with arbitrary slope. For lines with positive slope greater than 1, we interchange the roles of the x and y direction. Also, we can reverse the algorithm to draw line from right endpoint to left endpoint. Both xy decreases as we step from right to left. So we can do the same thing from top to left also, but the equations and the calculation will be different. And when peak is 0, we can choose either lower or upper pixel, but same for whole line. Okay, for a negative slope the procedure are similar, except now one coordinate decreases as the other increases. Right, remember this: if the slope is negative, one axis or one coordinate will decrease and another will increase. Here you can see this is the main point. The special case handled separately by loading directly into the frame buffer without processing. For horizontal line, we always take del y equal to 0 and for vertical line del x will be always 0, and for diagonal line it will be del x and equal to del y. So these are special cases, and that will be handled separately by loading directly into the frame buffer without processing. So we can directly load these things in the frame buffer if these cases occur. So now start this algorithm through an example. Suppose you need to draw a line AB with coordinate 8, 2, 2, D6, 4. So plot the point 2, 2. Now calculate del x equal to 4, del y equal to 2, twice del y equal to 4, twice del y minus twice del x equal to minus 4. Now P naught equal to twice del y minus del x equal to 0. Now P naught is not less than 0, so we select pixel 3. P naught means twice del y minus, this is 8, this is 4, twice del y 4 minus 4, that is 0, so it is not less than 0. We select this point 3, 3. Next, P naught plus twice del y, P1 will be incremented with P naught plus twice del y minus twice del x, twice del y minus twice del x, because this is not less than 0, then it will become minus 4. So now P1 is less than 0, so we select this point. Again we will increment P2 as P1 plus twice del y, because this is less than 0, as the condition given previously in the slide. If he is less than 0, we will take this part, so it becomes 0, so it is not less than 0, then we will take the diagonal point, and next it will become not it will become what, we add this part, it will become minus 4, then we will take next point, that is this point. So in that way we will follow and try to go through it again and again through different type of examples, because this equation, it is very important to remember while doing the calculation, these parts. And to understand this also, try to go through previous slides how we can find this P0 and P1 or Pk and Pk plus 1, and according to that we can follow the algorithm and try to understand what its significance, because it is important to understand. So if you have any doubt also, please ask me. Okay, and in next video or in next class we will try to explore more, or I'll try to give you more examples. Okay, and in next video or next class we'll try to go through the circle drawing algorithm. So this is all about in this video. If you have any doubt, and I think you will have some doubts, please ask me. We'll try to resolve it over Google Meet. Thank you.